Welcome. Today's lesson is about the vocabulary for formal proofs. The terms that we will use today are given, prove, statement, and reason. In a formal proof, there are usually two columns, and it was set up in this manner. The given is at the top. What you're supposed to prove is listed below that. And then you have a T-chart. That's your two-column proof. Above the top left-hand column is the word statement. That's what you're doing for each activity, for each number, and followed by a reason. You have to have a logical, mathematical reason for each statement. Here is an algebraic example. Given the set of all real numbers, prove that negative 5 equals 3n plus 1. Well, you set up your formal two-column proof in the form of a T-chart. Above the left-hand side, write the word statement. Above the right-hand side, write the word reasons. You have to justify each of the statements. You can't just say because. The first one is, you start with what you're given. You're given that the equation minus 5 is equal to 3n plus 1. What's the reason I can make this statement? Well, it was given up here at the very beginning. That's the reason I can say that. Then we go through, just like you would for a regular algebra problem, and solve the problem showing every step of work. You cannot leave out any step. You must show every step. So the first thing we do is we have to move this positive 1 from here to the other side. So we do the opposite, which is subtract 1 from both sides. And the reason for that is the subtraction property says we can do that. That gives us negative 6 is equal to 3n. The reason we can say it's negative 6 is equal to 3n is because we simplify. The next step, number 4, is negative 6 divided by 3 is equal to 3n divided by 3. The reason we can do that is the division property. To get from here to here, we get negative 2 is equal to n. The reason we can make that statement is because we did what from here to here? We simplified. And to get from here to here, step 6, n is equal to negative 2. Why can we say that? Because of the symmetry property of equality. This is an algebraic example of a formal two-column proof. Please go to Edmodo, find lesson 2.3, and do the check for understanding.